So when we first introduced ionic compounds, we originally just talked about the very simplest form that you can have. And that's going to be the ones where the ions in the compound are all monatomic ions. All right. And that's because all of those atoms were just single atoms that had a charge. All right. So an example of an ionic compound with monatomic ions only would be plain old sodium chloride. All right. The ions in that compound are sodium +1 ion and chloride -1 ion. All right. And the reason that we call these monatomic ions is if you look at the individual ions, all right, notice that each is just an individual atom, all right, whether it be sodium or chloride, all right. But the thing is, it's also possible to have ionic compounds with what are called polyatomic ions, all right. And we introduced polyatomic ions when we were doing the determining formal charge on molecules. A polyatomic ion is actually a covalent molecule, all right, that overall has a charge on it, all right. For example, if we have this one right here, if you look at the Lewis structure and you calculate where there's a charge, you would determine that there's a +1 charge on the nitrogen, all right. So we could abbreviate this molecule right here as NH4+, all right. And this is a polyatomic ion because it's a collection of covalently bound atoms that overall have a charge. Okay. The thing is that a polyatomic ion can function just like a monatomic ion in an ionic compound. All right. So in this place, excuse me, in sodium chloride, the +1 charged ion is sodium. All right. But recall that's got the exact same charge as this polyatomic ion. All right. So if we were to simply remove the sodium ions from this compound and replace them with these ammonium polyatomic ions, notice you're taking out something that's got a +1 charge, but you're replacing it with something that has a +1 charge. All right. So you could theoretically make an ionic compound which had this structure right here, where this entire group of atoms serves as the +1 ion. All right. And these compounds do exist, all right? This compound, the compound with this arrangement right here would be ammonium chloride. This image right here shows some ammonium chloride, all right? It has the properties of any of the ionic compounds that we've talked about so far. It would be something that would have a relatively high melting point, and it would be something which would also have very high aqueous solubility. So the way that we do formulas with compounds with polyatomic ions is very similar to the way that we do them with monatomic ions. All right. If you recall, when we have monatomic ions, all right, what you do is what's called the crisscross rule or the drop and swap procedure, all right, where you write down the ions with their charges side by side, and you essentially take you ignore the signs, and you take whatever that number is and you crisscross them. All right, so the number from here becomes the subscript over here, which tells you how many of that ion you need. All right, you take the number from here and you put it down here. For example, this will give you Na2S1, and then you simplify it. And one of the ways that you simplify is that you simply remove any of the ones. All right, so if instead of Na plus we had ammonium, well, the easiest way to do this is to write the polyatomic ions so that all of the atom quantities are inside parentheses, and you put the charge of it on the outside. All right, so what this is saying right here is that this group of covalently bound atoms, all right, which we talked about before, would have this structure, which overall has a +1 charge. All right, we're going to crisscross that with this ion right here. So the negative ion is a monatomic ion that has a -2 charge. All right, but we do the same thing. We take whatever the number is right here, and we're going to put it after the parentheses right here. And we're going to take whatever number is right here, which is assumed to be 1. All right, the plus just means a +1 charge, and move that down here. All right, so we would then get this right here, and then we simplify it the way that we have before. All right, which in this case we're just going to remove the 1 and show it without the 1 showing.